So as Anthony said, we had a couple ways to look at how we were going to design something that would do all this. So basically what we tried to start with was some kind of hardware design that basically used an RFID tracking chip on each rider. It would have an electrical box attached to it with a display system on the handlebars. The benefits, of course, it was accurate at the finish line. We could get hardware patents on it. You get a physical product in your hand, but looking at it with the costs and the design, it had a high cost to develop because of the RFID readers for developers and stuff like that were over $1,000 a pop. Using our entrepreneurial mindset, we had the hardware to sell. We could use overhead to build and ship. Maintenance costs could be a revenue stream. But as far as the obstacles went, we tracking at spots not near RFID readers would be hard to do. Tracking stuff in the pits, stats, stuff like that, fun stuff, may be a little bit more difficult to do. And then, of course, we had RFID reader latency, which, of course, Lee will get more into. So then we kind of came around to doing software. Basically, we could download an application to our phones or a tablet, whatever, what have you. The benefits, of course, there's no hardware. The phone has all the tools we needed, like a GPS system, a screen, stuff like that. The costs and the software design, there was a little trade-off because it's a little hard for electrical engineers to design and develop software. A lot of us aren't privy to knowing like software design like C#, which Apple stores require to put in their wrappers. Android that works best with C#. There's other programming languages that work better there, but I think going from C++ to C# would be easier for us. Again, too, with Going Software, there's no waste, no overhead, cheaper to maintain. We can get ad revenue in there, and it's better for the environment. Of course, the programming, the track routes are going to be a little tough to do. Pit roads, finish line, and then, of course, we're going to have to work with the refresh rate of GPS data. But getting into the results of it, I'm going to send you over to Leedy. Thank you very much. My name is Jaron Prescott.
Thank you. After discussing our project with our mentor, Dr. Harton, he reminded us about latency. Some RFID makers have a minimal delay because no data is being transferred. Since we will be using a unique identifiers for multiple riders, we will have to design around this. There's already a solution for runners, so this design idea is not new. Other problems that will include cost, lack of instantaneous data, increased cost of readers, along with pit stops or along the track for more up-to-date places of riders, and increased design if we wanted to track speed. Discussing the software, we will have been toying with designing most of the computing on the front end, meaning the phones do all the work. But having a server will free up computing RAM on handheld devices. We are still weighing in the risks and rewards with having a server control the places or do the blockchain method of computer on each individual device. Thank you. And here's Kevin Garcia with our discussion.
Hi, I'm Kevin. I'm here to talk about the discussion like Leedy said. So in talking about moving from the hardware to software-based design, obviously with the software-based design, you're not going to need to use as much hardware. Jaron touched base on this a little bit. So with less hardware, I'm sure a lot of you are aware right now that there's supply chain disruptions for semiconductors, and you can see that in the price of used cars and cars. It's all going up because semiconductors are very limited right now due to COVID and just supply chain shortages across the globe. So with less hardware, we're not really going to have to deal with that too much. There's also potential ad revenue streams. If our app gets big enough, which hopefully it will, we can have companies like Honda or just any other company that deals with motocross, hopefully will want to place ads in our app. So that's good income for us. There's also lower engineering costs. If you wanted to scale a hardware-based design, you would have to think about manufacturing costs. you would need more engineers, more factories, and more semiconductors, which all cost a lot more money, as opposed to having a software-based design where you really only have to worry about the server runtime and your engineers. So we would have that going for us. We also have more flexibility in our group, since we're a hybrid team. I'm sure most of you have noticed. Anthony's the only one in person there. So having that flexibility online for the rest of us was very important. If you have a hardware-based design, if the costs run too high, as Jaron was talking about, you would only have one person. Realistically, you would only have one person that has access to that hardware, and the rest of us would just have to try to follow along via webcam. Software is just easier for all of us to see what's going on, and we can all play a part in it as well. The cons of the software-based design, or just of this entire approach really, is that it's the first time for anyone in our group has ever built a app from the ground up. So this is going to be a learning experience for all of us. We're going to be learning new programming languages. Like Jaron said, C# is very important. So we're going to have to build on that knowledge. What's next for us? We are deciding whether we're going to go with the phone versus the cloud, or both. If you have access, we want to go with the cloud, but the thing is, if you lose access to the cloud, then you need a backup, which we're probably thinking about going with the phone on the backup. We also have to think about GPS access, how we're going to access the GPS that's already in your phone through Google and Apple, and whether we'll be given the permissions for that. Programming languages, there's other programming languages that port with C#. We have to think about, what we're all comfortable with and what we're going to decide on using moving forward. We've also got the software flowchart that we need to make, which will define our functions and how they're all going to interrelate with each other. So in conclusion, we have Sean Ancorn. I'll pass it off to him.
So hi, I'm Sean Ancorn, and I'm going to be discussing the conclusion. I'm going to be talking about some of our key results and the significance of our design, as well as the procedure we're going to be using moving forward. And finally, I'm going to be talking about the outcomes and what's next for us as a group. So our main key result is that we're deciding to go with a smartphone application rather than using hardware. Everybody already went over the pros and cons of this. It's just much more economically viable to use a smartphone approach. The significance of our design is that no product like ours currently exists for riders, which means they're kind of in the dark throughout most of their races. Using the information provided by our app, riders can make better decisions during the race because they'll know what place they're in relation to other riders. Like, for example, if somebody was in second and like they didn't see the guy in first, they know they need to overtake that guy to win the race. Our procedure, again, is using an app to keep costs down in different ways, like using the existing technology on the phone, like the display and the positional data provided by it. Again, our major outcome, a software approach using a smartphone base. This means for our what's next, we will be creating a programming flowchart, like Kevin said, for each member's functions, which will be like the positioning function, the function for determining what the tracks look like, and things of that nature. An aside is this photo was provided to us by Anthony's friend Nathan, who works for Studio 39. And these are our sources we used. Thank you for listening.